Hello, welcome to this video. In this series of videos, what I'm going to do is I'm going to try and design and build a Connect4 game. However, it won't be a normal Connect4 game. It will be one where you can change some parameters. For instance, you may want to set it to play 5 in a line, or you may want to make it find 3 in a line, or 6 in a line. You may want a smaller board, or you may want to play on a very large board. So this game, you'll be able to adjust the board to however you want it to be. The standard board is normally a 7x6. Okay. Now, I'm going to give a small summary of how I'm going to do this. And I'm going to start with here. Now, that's how I'm going to do it on a standard board. This is how a standard board would look. What we're going to do is we're gonna use a single array, and each square, that's each array. For instance, the first value, that's a empty square, so that's a 3, and that one there is yellow, and that's that one there. So the value of that array will be 1, and that's how we're gonna do the board. Now, you may look at this Connect4 board and you may think, okay, let's use a multi-dimensional array. For example, that one there would be, say for instance, it would be something like this. That square there may be 4, 3. So that will be that square, 4 and 3. So that's that square there, and we might just do yellow is 1. So we just do A3 equals 1. You could do it. You could do it that way, but I think when you're programming in, like this system is to do this game. It's one of them things where when you start off doing it, you sort of do bit by bit by bit, and sometimes you start it and you don't know what you're gonna do. You don't know how it's gonna end until you get close to the end, and you can see the end. So it's one of them one. It's like sometimes you might do something, you can see you're going to do this, and then at the end, and then you're going to say you're going to use a multi-dimensional array, and at the end you can see all the way to the end, so you then use a multi-dimensional array and it's fine and it does its job. But in this case, I can't see how it's going to get, I can't see what's going to happen at the end, so I'm going to be doing a lot of steps. And after them steps are complete, then the game will be working. And then there may be a couple of bugs, and then I'll fix them bugs, and eventually it will be working. But at this point, I cannot see the end. So because of that, I will not use a multi-dimensional array for this kind of thing. So the board is a 7x6. That could be a multi-dimensional array, but I'm not going to use one. Okay. So what I'm going to use is, I'm just going to use a single array, and it's going to be represented there. Now, on this board, we need to find 4 in a line, and we need to find, for example, we may set it to 3 in a line, or 5 in a line, or 6. So we need to know how to find 4 in a line. Now, if we was just doing a 7-6 board, we could just do search all them squares. Search, oops, hold on, oops. We could just search all of them, that 4, and then we search that 4, and then it's the same here. We do a loop here, and then we do a loop here, loop there, loop there, loop there. And we go down the same way, and loop down. And then you might think, okay, it would be easier to do that on a multi-dimensional array, and you're right, it probably would be. But we're not going to use that method because obviously we're going to have to find diagonals as well. And we could do all that, but if we're doing it on different boards, it would be too much code. or it'll be too complicated. So what we have to do is we have to break it down. And how I'm going to find 4 in a line, I'm gonna use this square as an example. From this square, you've got 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm just going to talk about one of them, 2 of them, the directions. I'll do it on this board. It's that direction there. Just look at the square 24 and look at that direction going that way and that direction going that way. As you can see, going this way increases by 1. Going that way, you take away 1, so it's multiplied by -1, so it's 1 and -1. Now if you notice something, if I go to 24, 25, 26, 27, 28, you see that? So if I had a red, if I was going through the squares, it would count that as 3 in the line. So we need it to stop here. We need a way through it. So if we're searching along this diagonal here, when it gets to here, how do we detect this to say, okay, stop? So we have to find a way to search for 4 in a line. Okay, I'll just talk about this one and -1 and +1. If I said +1, search for +1, it will go there, 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 and it will find 4 in a line. But however, what if I said start here and it went 1, 2, and then how would it know about 27 and 28? How would it know about this? We could do some code and work out the edge and work out then if like for instance, the length of this is 7. Right, okay, so the width is 7, so we know that's 7. So we know anything modulo 7. In fact, so it would be quite complicated. So what we're going to do is we're going to simplify it by we're not going to use a 7 when we use a 7x6 board. We're going to actually use a 9x8 board. So for instance, what we would use to do our board, we're going to represent it with a 9x8. So we're going to use 72 squares. And this way it solves the problem. For instance, if I'm looking for 4 in a line here, if I'm looking for how much like squares are here, you go 1. You know, if I was looking here, it would look at that, it would look at that, it would look at that and say, oh yeah, that is the border. So it will stop. Or if I was coming here, 28, 29, 30, and then it will stop here, it wouldn't run down to here. So that's how I'm going to code it. I'm going to use a one-dimensional board, and it's going to be an array, and this is how it's going to go. At position 3, the value is 1, and that means that it's going to be that square, and all the squares are going to be mapped. Okay, thanks for listening to this video. I'll carry on the next one. Okay, bye.